it said solve the following system of inequalities graphically on the set. And then we want to state a coordinate that is in the solution region. First and foremost, what we have to do is that we need to graph these, right? So let's graph them. So I'm focusing on this one. All right, so because I see this here, 2/3, right? 2/3, that's my slope. And remember, slope is always rise over run. So we want to make sure that we remember that our slope is our rise over run. So the top number is the rise. So in this case, I'm looking at 2/3. So my top number is the rise and my bottom number is the run. Also, we have a very important detail here. That's -7. -7 is my B value, which is my y-intercept, right? So it crosses my y-axis at -7. So what I want to do is to highlight my y-intercept right here. So this is my y-intercept at -7. From -7, I'm going to rise 2 and run 3. Take a look. I'm going to rise 1, 2, and then run 3. 1, 2, 3. This is my second point. So all I have to do is to take a ruler and then use a ruler and draw a nice line through this. So let us get our line going from actually y, which is equal to 2/3 x minus 7. If you notice, I didn't use the inequality there because inequality is a region. So what I did was I graphed the line associated with the inequality. It is simply by just replacing my inequality with a equal sign, and then I get the line associated with it. And from that, I could move on. Another thing I need to make us aware of is my solid line here. I'm using a solid line here because there is a bar underneath my inequality. So because it says greater than or equal to, then I have to use a solid line to represent that idea. All right, so I'm going to be looking at this one. It says y is greater than or equal to -1/3 x minus 4. Again, rise over run. So this is my slope here, but it's negative. So I'm looking at -1/3, right? So I'm still looking at 1/3, but this time it's negative. So because it's negative, I'm going to go down 1 and then run 3, right? So this -4 here is my B value, which is my y-intercept. So that's where this one crossed the y-axis. That means I'm going to start at -4, which is right here in blue. And from there, I'm going to go down 1 and then across 3. Let's go. Down 1, across 3. 1, 2, 3. So it's right here. All right. And then I could go down 1 if I want and across 3. 1, 2, 3. And I could continue in that fashion. But let me just quickly grab this line here. The line that is associated with this inequality. So this line is actually, so it's going to be y is equal to -1/3 x and the minus 4. So here we have the two lines, right? So these lines will help us now to shade. Let us shade. So for this line here, we're looking at greater than, so I'm going to have to shade above it all the time. So I'm going to have to go above this line all the time. So it is suggesting that the solution is above it. So I'm just pointing arrows to indicate the idea for that solution. It's above it, so I got a shade. I'm pointing to the region. So from that region where the line is going forward, the solution is editing those directions. Now for my second line, it also said y is greater than. So because it says that, I have to shade above it to show the solutions. So the solutions for those is actually above that line. Remember, we're looking for a region where the two set of arrows are pointing. So you could see that this is a no because it's only one one set of arrows are pointing there. This is actually a no region as well. This is actually a no region as well. The only yes I have is on top here. I'm seeing the green and the blue linking together there. So the solution is all the way in this region right here. This is the solution region, right? So here's the ideal. Because I've now isolated the solution region, I need to find a point that is in the solution region. So any point I can name, and I'm just going to name this point right here. I'm going to name this point right here, right? So this point is 5, 2. So I'm naming 5, 2 right here. That's where 5 meet 2. So in answering this one, 5, 2 is a point that is in my solution region. It's right here. So there are infinite solutions for this. You could name any point that's in that region for your solution. All right, so solve the following system of inequalities graphically on the set of axes below. State the coordinates of a point in the solution set. All right, so let's take a look at what's going on. So we have 1 here, we have 2. So let us take a look at the first one. So the first one says y is greater than 3x minus 3. First and foremost, what we want to do is to make note of what we have. Remember that we're going to have to graph this. So in graphing this, we need the slope. The slope I'm looking at is right here. That's 3, which really means 3 over 1. So I'm going to represent remember, our slope is rise over run. So basically 3 over 1, 3 is the same thing as 3 over 1. So we're looking at having 3 over 1 right there. All right. Also, if you notice, we have a negative 3 here, and this is my b value, which is my y-intercept. All right, so my y-intercept is at negative 3. It is suggesting that that line will cross the y-axis at negative 3. The equation that is associated with that inequality is y is equal to 3 over 1 x minus 3. If you notice, I switch out my inequality right there for the equal sign because an inequality is just a region. And I'm going to draw the line that is associated with that region right now. So first, after noting my negative 3, which is right here on my y-axis for my y-intercept, I'm going to use rise over run. Positive would have meant that I'm going to go up 3 and then across 1, right? So I'm going to rise 3, 1, 2, 3, and then I'm going to go across 1, which is right here, then around 1, which is right there. So all I have to do is just to draw a line through those points and I'm good. Bear in mind that there is no bar underneath our inequality here, which suggests that it has to be a broken line that we need to use. So that is my line that is actually representing that inequality. So this is actually y, which is equal to 3x minus 3. And notice it's an equation for that line. Now let us take a look at the other line. Right? So we're going to be looking at the other inequality. So the other inequality, I'm going to write it beneath. It says y is less than negative x minus 7. Negative x really means negative 1 over 1. So that is my slope. So my slope is going to be a negative 1 over 1, which means I'm going to go down 1 and then across 1 because going down would mean a negative right there. My b value, which is my y-intercept, is negative 7 this time. So let us switch things up, negative 7. So what this is, I'm going to go down 1 and then across 1. Let's take a look at it. So I'm going to go down 1 from negative 7 and then across 1. I could do another down 1 and then across 1. So you could see what's going on. So let me draw a long line through that to represent my inequality or represent the region that I'm about to shade. It has to be a broken line because there's no bar underneath my inequality, as you could see. So this is the line that we have right here. Now, let me label this. So this line is representing y is equal to negative x minus 7. Now, what we want to do now in order to know the idea, in order to know the region of solution, we have to shade. Bear in mind that for number one, in this case here, it says y is greater than. So that's my red line. I'm going to be pointing on top. So I'm pointing this way, above the line, right? So the solutions are above the line for that one because it says y is greater than. So my solutions are above that line, heading that way. Let's take a look at the other case, which is number two, this one. It says y is less than. So if it says y is less than, that means my solutions are pointing downward, going this way. What we're looking for is where we're looking for regions where the ideas are overlapping. That's all we're looking for. So we can isolate places. For example, at this moment, we could say, look, both arrows are not pointing in this region. So that's not it. Over here, both arrows are not pointing in this region, right? But I notice in this region here, I'm getting a yes right here. So everything here, this is the region that is satisfying that idea right now, where the green and the red arrows are mingling right there together. Now, we want to pick a point that is in that region. So all I'm going to do is just to pick any point. So I'm going to focus on -6, -4 right here. So -6, -4 is right here. So a point that's in that region is -6 meets -4. So I could just put it right here. That's -6, -4. That's a point in the solution region. Thank you for watching. See you next time.